Hello students, we are going to study the Cannizzaro reactions today. We can easily identify the Cannizzaro reactions by some concepts. In that concepts, one is in the reactant part there is a two molecule of aldehyde. Reaction condition there is a strong base. In the product one is the alcohol, another with the acid. One is the alcohol, another with the acid. Means this condition is very helpful to identify this is the Cannizzaro reactions. This is the Cannizzaro reactions. So the friends, it is the important part. We can easily identify any reactions. In these reactions, we have studied the three reactions up to now. One is the Noventhal reaction, one is the Claisen-Smith reaction, and third one is the Cannizzaro reactions. In these three reactions, one important thing we have to remember: in each reaction there is aldehyde and ketones. In the reactant there is aldehyde and ketone, but difference is that in the Cannizzaro reaction there is a two molecule of aldehyde having no alpha hydrogen atoms. Having no alpha hydrogen means is a condition, a special condition. Means like if the molecule is given benzaldehyde, here is the molecule, means benzene react attached with the aldehyde, having the one hydrogen atom, having the one hydrogen atom, having the one, having the one, having the one. Here is also one, but it is attached with the carbonyl carbon. Means here is no hydrogen atom. Which carbon atom is called as alpha carbon atom? The carbon atom adjacent to the carbonyl group. The carbon atom adjacent to the carbonyl group, which is called as alpha hydrogen. Means the carbon having adjacent, no, here is no adjacent, means no alpha here. Here is the one first carbon, that is alpha carbon atom, but this alpha carbon atom not attached with the hydrogens, means here is a no alpha hydrogen atoms. So in the Cannizzaro reaction, here is the special conditions. Condition is that this is a special condition. This condition is that the aldehyde group without alpha hydrogen atom. Okay friends, whenever we have to understand the named reactions, there is a lot of reactions, thousands of the reactions, named reactions, but we can easily identify each reactions by find out the difference between them. Difference is that the reactant part, reaction condition part, and the product part. Reactant part, reaction condition part, and the product part. These three parts very helpful to identify the named reactions. Okay friends, whenever you are studying any named reactions, you have to focus on the three parts, that is the named reaction parts, that is the reactant part, reaction condition parts, and product. In this condition, reactant part is that two aldehydic molecule is there. How we can understand is the two aldehydic molecules. This is the two aldehydic molecules having no alpha hydrogen. First important key means having the aldehyde but no alpha hydrogen. One reaction conditions. Another one is the strong base NaOH. And third one is the alcoholic product, another one is the acidic product. Means the conversion of aldehyde group to aldehyde group. One aldehyde group is converted into the alcoholic group and another one is the converted into the acidic group. This condition, whenever we find this condition in any reactions, multi-step reaction or any aldehydic molecule in presence of strong base converted into the one is into the alcoholic group, another one is the acidic group. At that time, without taking a fraction of second, we can easily say that this is the Cannizzaro reactions. Without wasting a time, we can easily identify this is the Cannizzaro because we know that the conditions. Okay, so always keep in your mind each name reaction easily identified by some keys. These keys we have to keep in your mind. Here is the key is that aldehydic molecule with the strong base, one converted into the acid, another one is the alcohol, but this alpha hydrogen, this aldehyde having the no alpha hydrogen, this condition is only for the Cannizzaro reactions. No another reactions shows these conditions. This is the key of these reactions. Okay friends, NaOH is the strong base. The strong base is also, it is NaOH also called as alkali. So in these reactions, NaOH strong base, if we divide the NaOH, we will get the ions Na plus OH minus. That OH minus will helpful to act as the nucleophile, because here is no proton available, because no alpha hydrogens, that's why it cannot be act as the base, it is act as the nucleophile, and there is no removal of group is there, that's why it is only addition reactions, and nucleophile is there, that's why it is a nucleophilic addition reactions. So students, when aldehyde without alpha hydrogen atom are heated with the concentrated alkali with NaOH or the strong base, they undergo the self-oxidation reduction to form the alcohol and the salt of the carboxylic acid. One is the alcohol, means understand oxidation reduction reaction. This is converted into the alcohol, it is the reduction product. This aldehyde converted into the acid, this is the oxidation product. In Cannizzaro reaction, oxidation reduction reaction takes place. This is the reduction, this is the oxidation. Oxidation reduction reactions takes place, called as the Cannizzaro reaction. Is the mechanism are given there. We know that NaOH on splitting we will get the Na plus, because it is a metal, electropositive metal, and OH minus, that is it is a anion. Both are the ions. Sodium is the cation, OH minus the anion. This ion is here, OH minus. This OH minus is the act as the base in sometimes, and sometimes it will act as the nucleophile, but in this condition it is act as the nucleophile, because we know that the function of the OH will be act as the base also, act as the nucleophile also, but it depend upon the its supporting part, that is the reactant part. If in the reactant part there is alpha hydrogen atom, if in the reaction part there is alpha hydrogen atom, at that time it is act as the base. It is act as the base. We know that because base always like a proton. बेस को क्या पसंद है, प्रोटॉन पसंद है. तो OH माइनस को जब भी whenever OH minus get the H plus ion for the abstraction process, at that time OH minus ion will be act as the base. Okay, but in this condition There is a special condition is mentioned that this reaction having no alpha hydrogen atom means no doubt there is no proton available for abstraction of OH minus, means it cannot be act as the base. Only one reaction, only one is the condition is remain here, that it will be act as the nucleophile. If it is act as a nucleophile, if it is act as the nucleophile, then there should be electrophilic center. So we can find easily electrophilic center here. Carbonyl carbon is the electrophilic center. The OH minus attack on this carbonyl carbon, we will get the oxyanions. But this oxyanion is unstable. This oxyanion is unstable. It cannot remain as it is in the form, because here is OH minus, here is the OH, means carbon attached with the two electronegative atoms, it facing the instability, so it will be rearranged so that it will be stabilized. So for that it proceed the hydride ion shift, means here the two options are there. OH minus reverse this process and remove the one of the group. So first in your mind we can remove the OH minus, the no sense of the reactions, means no product formation, no any step proceed, means reactant remains as it is. If reactant remains as it means no reactions, and at that time if there is no reaction, so no sense of the reaction, means we cannot remove OH group. Second part, we cannot remove the C6H5 because it is a very bulky group, it's alkyl group. It's very difficult to remove the alkyl groups because the leaving capacity of the alkyl group is very less. pKa value, pKb values are very different. That's why we cannot remove the alkyl group, that is C6H5. So we can aryl groups, we can remove only hydrogen atom, but removal of hydrogen atom also cannot be takes place easily because there are very few reactions in the all the reaction named reactions, very few reactions in which hydride ion is removed. So in this condition hydride ion means H plus ion is removed, and this H plus ion removed, it shift from in the H minus ion form attack on the another carbonyl carbon. It will convert it into this, converted into this, and it is converted into the acidic part. Last step is that we have to abstract the proton and convert it into the alcoholic part. In that way, there is a formation of alcohol and acid. Here are the two reactants of aldehyde, one converted into the acid, another converted into the alcohol. Another one is the two molecule of aldehyde, one converted into acid, another one to the alcohol. Next one, another example of their one molecule having the two aldehyde group, one aldehyde converted into acid, another one into the alcohol. So the friends, this is the kinetic reactions. Do the practice regularly. Thank you.